Good afternoon. People are still coming in. So I guess this is our fourth new to Trenchless Industry Network overview session. So this one is on the third kind of facet of the ISTT website that we've been going through. So on site investigation and condition assessment. So we have some good overview presentations on it following the ISTT site. And then we have some kind of industry expert speakers to give a different perspective on site investigation and assessment, following the structure that we have on the other ones. But just as a quick kind of overview, we'll go through some housekeeping and then some introductions. So I am Silvana. I work for Sewertronics and Minicam Group, but I am the kind of program lead on the New to Trenchless Industry Network. A bit of a tongue twister. And I'll be, there we go. So I think we're all doing pretty well in the muting, but just a reminder, please keep your microphone muted if you're not speaking. The team with UKSTT will share the slides and web links after the meeting. But please make sure your contact details have been registered and provided. If you're here, it's likely that they have been, but if you have not registered with the UKSTT, please give the details to admin@ukstt.org. And if you're interested in CPD certification for this, they are available for people who have attended these mini kind of courses. So please email that email address there, admin@ukstt, for your copy. Another thing, we will record the presentations. I think they'll start kind of once we get into it. The housekeeping doesn't need to be recorded, but we will not record the discussions afterwards, just as a heads up. So very briefly, what will we be talking about today for the next 2 hours? Welcome and introductions. We'll kind of recap on what the network has been, what we've done over the past 8 months, and kind of maybe open it up to discussion at the end of what do we want to do in the future. Because I think we've had a really good last 3 sessions covering rehabilitation, site assessment, and what else kind of would you like to see from the network? So that'll be a good discussion. The meat of today's discussion will be an overview on site investigation and condition assessment with some expert presentations and then a Q&A. So hopefully there'll be some good discussion there. So very briefly, I feel like if you've been to some of these before, you've probably seen this, but if you've not, this is kind of what this network is all about, to support those new to Trenchless, to develop an enhanced understanding of Trenchless technologies, create a better community within the UK Trenchless network, and basically create a more aware population of learning opportunities to solve Trenchless challenges of the future. So it's all about making sure that those newer to the industry feel supported, understand different options and different techniques and challenges that we have going on. So that's a brief overview of the network. What have we got going on? So we have these online bi-monthly meetings. This is our 4th one. We've been kind of trying to bring them a bit into real life. So at the last No-Dig conference in Sheffield, there was an opportunity to meet at the University of Sheffield, learn about their center they have there. And I believe I was not there, unfortunately, but I believe it was quite well attended. So trying to bring some of that education out of Teams into real life and incorporating some fun social events with that as well. So that continuous education piece as well. Something else we're looking at with potentially more future in-person events is different mentoring opportunities. So those on the call may be interested from either side. So hopefully that's something we can tie in the future. So in this meeting, we're talking about kind of the scope of Trenchless specific to site investigation and condition assessment, and we'll be using ISTT resources to kind of guide that, that Ian will get into in a second. We want to advance the practice of Trenchless for public benefit, but also promote education, again, focusing on public benefits for that. So our fifth, online bi-monthly meeting that will happen in September will be focused on the benefits of Trenchless, tying in nicely with these objectives. So what's in scope for Trenchless Technologies? This is a very brief overview. So we've done online bi-monthly meeting on new install. We've done one on rehab, and today will be on investigation and assessment. So kind of what does that all include? And as you can see in the smaller diagram, all these benefits of reduced disruption to customers, reduced disruption as well. Sorry, I think someone may not be on mute. If you could please mute yourself. Thank you. I was getting a bit of an echo. So yeah, trying to think about not just the technologies, but also their benefits as well. The ISTT is the largest society that the UKSTT is part of, so this is quite a international scope with the ISTT. There are multiple other national societies that have groups like this that we're trying to learn from and take different initiatives and ideas from them. So the North American Society, the Australasian Society have groups like this. So it's been very exciting to hear about what they're doing. But I think as well, just within the UK, there is a purpose wider beyond with the ISTT. So if you're interested in kind of growing your company's footprint or anything like that, the UKSTT and the ISTT are great resources for that. Here's a picture. I think Ian has taken this. It's really showing the footprint of the ISTT at a international council meeting, I believe. Looks a bit like the UN or something like that. So
yeah,
big
UN of Trenchless Technology meeting in Finland about 3 years ago.
And here are websites for more information. I believe we'll go into one of them later, the ISTT website, but the UKSTT site has UK-specific information, and the ISTT has great resources that Ian will talk about in a bit to really overview Trenchless technology. Here it is. So as you can see, if you want more resources from what we're going to be talking about today, if you would like to elaborate further on that on your own, there's great information here. Ian will give a bit of an explanation of how it's kind of all set up in a bit. But you can go into each one of these tabs and find papers related to the technology and find brief overviews related to it. So it's great if you kind of work in one sector of these, but don't know that much about pipe reaming or pipe extraction or anything like that. So we're all kind of new to some aspects of Trenchless in some way. Plug for some in-person events. The No Dig Roadshows we had Belfast and Sheffield, and we did have kind of in-person new to Trenchless networking events at both of those. We have the No Dig Roadshow in Bristol coming up in October, and we're planning some potential in-person visits as well with that, so stay tuned for more information on those learning opportunities and networking opportunities there as well. So yeah, we had the opportunity at Sheffield, and there will be an opportunity to meet at Wessex Water the afternoon before the No Dig Roadshow in Bristol. So that will be quite interesting to meet with the Wessex team and hear what they're working on down there. So today specifically, what will we be talking about? Site investigation and condition assessment. So Ian will be getting into kind of the nitty-gritty of that I've alluded to on the ISTT website resources and kind of a very brief overview. And then myself and other experts will be going into different technology overviews. So yeah, thanks, Ian, and I'll let you take it from there.
Unmuted. Okay. So hopefully you can see my presentation, can you? Hello?
Yes, we can see your presentation.
Jolly good. Okay, well, I'll make a start then. Thanks very much. So I'm doing a double presentation, actually. Tim Sargent, our vice chair, couldn't be here today, so he was going to do the site investigation and I was doing the condition assessment, but I put our slides together, so I'll present for both of us. And just as a reminder yet again, what we're doing, as we have done in the March and the May event, is we are following through the technologies which are available on the ISTT website. And I often bang on about this, but if one of your roles is to consider the options, the full range of options available for any given situation, then this ISTT website is an absolutely ideal place to make sure that you are taking everything into consideration. And what I would point out is that what is on here is a synthesis of discussions between the 28 societies. The contents are regularly reviewed, but monthly meetings of the ISTT Technical and Education Committee, and it goes into minute detail. And if you disagree with some of the wording, it might be because we've had to compromise on the use of English language, which is acceptable to everybody, as techniques may appear under different names in different parts of the world. Also, there may be something missing. If you do come across something which you feel is missing, then do get in touch with UKSTT. And as pointed out the other day to me, which I forwarded on to the group, somebody said, what about blocking up of disused assets, where you fill them up with concrete, or you put some kind of a block on a lateral? So we're now considering including that on the list. So site investigation and asset condition assessment. Perhaps in an ideal world, we'd have them separated, but for convenience and fitting onto web pages, they've been put together. So let's just remind ourselves, the site investigation is looking at where are these pipes or these conduits? Where do they go, and what are the ground conditions around them? And then we have asset condition assessment, which is looking at the actual situation of that asset that we are considering, which we need to do some work on. And one of the things I would say about site investigation, and this goes back to our March meeting, is site investigation is particularly important when you're doing new installations, which I won't go into the details, but it is things like the directional drilling and the micro tunneling and the other methods which allow us to put in a new pipe without trenching. But hell, you need to know what's there. Not only the ground conditions, but where are the other assets, and therefore is it feasible? When it comes to condition assessment, that is more related to existing assets, and therefore condition assessment is more about making a decision about an appropriate repair or a rehab. So let's have a quick look at site investigation. So it's what structures or utilities are there, and what are the ground conditions. I'm going to flick through these slides fairly quickly, but they will be shared afterwards. And you can also just use the ISTT website to keep yourself up to date with this. So when we look at site investigation, you will find when you use the drop down on ISTT that it takes you to asset location and it takes you to asset environment. It is divided up the technologies under these two subheadings for site investigation. So first one on here is asset tracing. And there's a whole variety of methods which are possible. So essentially what we're looking at, sonde techniques, this is where you might attach something, say, to a camera, which will be able to determine its vertical and its horizontal position as it goes through a pipe. We've got the impressed signal techniques. This is where you actually create a signal from within the pipe and you can detect it from above. There's a whole variety of further sort of internal survey techniques for determining location and tracing them. And we will be hearing a little bit about that when we hear about drones, for example. And then don't forget smoke and dye testing. I've used dye testing to try and work out where a sewer connects into a stream before. You can use smoke detection. So there's a range of perhaps expensive and complex or relatively cheap solutions. And so we're looking at this initially, asset tracing, from within, but let's not forget as well that we can search directly from above. So we've got ground penetrating radar, seismic or sonar techniques, and there are a few additional methods that you will find appear on the ISTT website. And let's not forget, something like we're going underneath a river with a new installation. We want to know something about this water body. So you're actually having to trace, in this case, where the surface of the ground actually lies. Or we've got a variety of other ways using seismic or electromagnetic signals to determine what is going on. And we can, in that way, actually find. And remember, at this stage, I'm not really talking about we're talking about finding where things actually exist. And the ISTTs included potholing or keyhole as a method of getting in to find the location of an asset, just where, if necessary, going down with something quite small, so it's less trench, not trenchless, to locate where something is. So if we then look at asset environment, ground investigation, so we've got geophysical, geochemical. Let's remember we're interested in the chemistry because it may determine what type of pipe product can be used. And it may be as well necessary to do some soil sampling in order to come up with the answer. So here we're potentially looking at things like coring in order to understand what is under there. And this will determine where perhaps it is safe or easy to undertake a trenchless technique. So just a little bit more detail on this. We've got things like electromagnetic survey, which allows us to both do topography, but also to do perhaps some assessment of the situation of the pipe. And this can be done from the inside and from the outside of the pipe. Thermal and infrared. This is perhaps the one that we're most perhaps commonly aware of. Here on the right, we've got a pipe bridge. And here we've got some various assets within a road and some very specific assets, again, using heat to determine what is going on to find your target for rehab and repair. And then still under this site investigation, the ISTT has groundwater monitoring. Can be an extremely important element of this. It may be that you actually need to install some additional wells in order to be able to monitor groundwater, particularly if what you're doing is trying to deal with a particularly severe infiltration issue, and you want to choose a time of year when it is conditions best for going and doing the work. And you can put all of this together into mapping. And let's just remember that you can use multiple techniques in order to come up with the answer when what you're looking at is investigating a site. And I say we mentioned a site. It could be that you're looking at something which is many kilometers long. Let's not forget that when you look at some of this mapping here. A variety of techniques in order to locate where existing assets are, but also to identify what the conditions are if you're planning to lay something new. So that's a brief run through site investigation. What about condition assessment? This, by the way, is another way in which the ISTT sort of presents its. This is more from a spreadsheet, and I believe that is actually now available on the ISTT website. For a while, it was replaced by the page, which is very, as you say, long and thin. But they're also, I think they've now put this back up, having a more sort of easy to look at graphic. So when it comes to the condition itself, it's divided up into inspection, visual laser inspection, structural condition assessment, and operational performance. Let's not forget at the end that you actually want to know, you might want to know how the asset is performing as well as its actual structural condition. So is there infiltration? Is there leakage going on, for example? So the scope of condition assessment is quite wide. So you'll be maybe the most common one, of course, is collecting and interpreting visual images. But increasingly now, people are realizing that visual images, perhaps alone, are not necessarily everything you need, and that there may be other ways, rather than making it visual, of recording data and information. So let's just be aware of that. You might want some precise geometrical information, and you will may particularly be interested in pipe wall condition, the material itself. So we get some overall visual images of what's happening. You get some precise geometry. You find out what is actually happening to the pipe wall itself. And then there may be some operational information which is available, such as blockage rates, or as I've mentioned, infiltration, etc., which is going to help you to understand what is going on with the defects or what the consequences are. And let's just remember as well, this can be a periodic, or it can be a continuous or automatic inspection, or it can be autonomous. And continuous automatic these days, there's so much, for example, going on with water pipe, wastewater pipe, and with gas pipe in terms of monitoring flows. And flow is and what is happening, and maybe blockages occurring, is a very key measure of condition. And let's not forget the autonomous. For those of us who went to Sheffield last month and saw the presentation there, they're dealing with the pipe bots, and they're trying to create autonomous robotics that in future will be continuously monitoring condition. So essentially, by accurately understanding condition, this allows us to predict deterioration and make decisions and make financial plans for maintenance, repair, rehab, or replacement. And the maintenance can be just cleaning. The repair can be a short-term permanent, you can rehab, or you might decide you've got to actually replace. So if we look at condition condition assessment more generally, we start off here with the inspection application. So the choice of the method that you are using will very much depend upon the purpose of the inspection, but also the type of facility that your inspection will take place in. So, and the type of facility, for there I mean, what is the material that it is made of, what are its dimensions, what is it carrying? And something which is often suggested, and this is something which has been highlighted by the ISTT as a preliminary investigation. So the budgets are limited, and it may be necessary to come up with something simple as a quick look, which then might lead into making a decision about a more detailed condition assessment and use of perhaps more expensive techniques to help justify why you might do it. So the most commonly used method at the moment is CCTV. And CCTV, of course, comes in various forms. You can, for large diameter, and you can also do very, very small inspections using push cameras. And there is a sort of section on manhole and chambers. Now, manhole and chambers are not specifically, if you like, trenchless or trench. They are a trench. They're a permanent hole in the ground, which can be inspected. And something that's increasingly happening is they are being regarded as vital infrastructure of their own, but also an opportunity for quick inspection. So things like zoom cameras or a quick laser survey down the manhole itself. You can survey the manhole while you're visiting it for another reason, or you could drop a zoom camera down and zoom up and down by changing the zoom to see up or down the pipe that you can see either direction. So a number of, if this is an example of a, let's say, a limited budget preliminary assessment, get you guys just to check the pipe that they can see from the manhole if they're going there anyway. And one or two of the water companies are starting to think that way and starting to invest in equipment to allow their staff to do that. So looking at these, we've got the visual laser inspection. So CCTV, zoom cameras, I mentioned nozzles, and there's laser and LiDAR. And in the following presentation, we're going to hear a little bit more about the use of LiDAR. So normally you're looking at something like visual images or line of sight scanning methods, and usually an operator will be in direct control, but as I mentioned before, increasingly we're starting to see automatic data capture and more AI coming into this, which is something we need to bear in mind. And I think this whole condition assessment area is where AI, as we know it's been developed for CCTV, it's going to be AI helping to control the way in which the actual surveys are carried out. So with CCTV, basically you've got a camera and some form of transport for that camera, connecting cables, recording equipment, monitor, software, capturing what has been seen. And either the operator or artificial intelligence can be used to create the coding and the records. You may require to do some pipe cleaning before CCTV inspection. And let's just bear in mind, cleaning is not here in this particular list, but cleaning is and can be an essential prerequisite for undertaking a condition survey. And just another point here about lighting with visual can be a key issue, but not so with other types of survey. With the zoom cameras, I've already dwelt on this, but they get a specific mention here, and it does allow preliminary information to be gathered. And it might tell you there's some infiltration, it might tell you there's some blockages, pipe wall displacement, rapidly identified, but you can really look from a point of access up and down. You would need to carry on with something else to get round a bend. And these small forward-facing nozzle cameras, which can be pushed through, can also be are also given a sort of separate entry within here. And when it comes to laser and LiDAR, this is particularly helpful for pipe dimensioning. I've mentioned earlier about locating position of the pipe, which we need to do, but actually using laser LiDAR in order to get a very good profile. So the dimensional analysis will allow you to therefore design a solution, particularly if you've got things like changing diameters or unusual geometries partway along a pipe section. And with both the visual and the laser, just a sort of reminder that there's a whole range of platforms upon which they are carried. And this is something as well you need to sort of think about. Is it's all very well that we've got a survey method, but how are we going to deliver it? So we've got the crawlers, the push and push-pull inspection. We've got satellite cameras. So you're trundling down, using your camera down a main pipe, and you see something in a small lateral which you want to have a look at, a little satellite camera that can go off and have a look up that. And let's not forget the floating platforms, which can be used. And there are now submersible, we think a lot about floating, but there's submersible drones for looking at getting down under the water level and looking in structures, say, for example, big underground tanks. The drones flying through, we're going to hear about, and I've had a little red box down there, the autonomous element of it. So will it be possible to have autonomous floating boats, drones that are increasingly AI is being used to help to fly them? So autonomously flying drones and autonomously moving robots. So much for the visual. We've then got structural. So under here, the ISTT divides it into wall condition and thickness censoring, structural sensors, and it's determining external voids. And let's just mention the voids. It's one thing to know what is happening with the pipe, but to know if there is a void around the outside of it, which is either been influencing and causing a problem, or could potentially cause a problem and therefore needs to be fixed, is an important part of it. So it's going beyond the pipe itself. So with wall condition thickness, we've got a range of ways of doing this, but essentially what we're trying to do is to get reflections and refractions and wave disturbances from generating a wave, be it electromagnetic, acoustic, infrared, or nuclear, using radiation sources. And the nuclear bit here is basically every time we have to go and have an MRI scan or whatever done to us, they're using nuclear methods, and these methods can be used for assessing the condition of infrastructure. So a selection of purposes which can be applied in different situations. So the electromagnetic, for example, is used in critical high-value pipelines, such as oil and gas. The acoustics, the simple way is to get down there and whack it with a hammer and listen. After all, it's what they do on the railway lines. But you can do it as simply as that, or using calibrated impact of a metal ball. But increasingly, acoustics are being used in instruments and fitted to crawler cameras and other methods to determine, for example, where leaks are. The infrared scanning will tell you about both the pipe itself, but it might tell you something about the land, the ground around it. So that was wall and wall condition and thickness. And then there's structural response sensors. So let's not forget, I mean, a bit like just as they do, putting a bit of tape across a crack on a wall of a house to see whether it's expanding and see if the piece of tape breaks. This is the sort of thing that we can be doing. So where personal access is available, you can have discrete strain sensors attached to the inner surface. And we can be using crack width gauges, strain gauges, etc. Acoustic comes in again here. Fiber optic can be used. It can detect stresses and strains. And ISTT considers that this is a particularly promising area for the future, and that they're expecting to see further developments coming along. Getting towards the end here, we've got the external void detection. So this has already been covered to some extent under site investigation, but here we're looking particularly close in. So we're not looking at what's going on around with the soil. We're looking at what's happening around the pipe. So again, the ground penetrating radar, you can use in-pipe ground penetrating radar, the infrared scanning, ultrasound, and the nuclear methods again, in order to try to determine where a void may exist or whether a void is suspected to exist. Obviously, particularly where we get these cave-ins in sewers or formation of sinkholes, this is the type of thing that people are particularly interested. So we've got ground penetrating radar, which I've mentioned, the two types. We've got the infrared scanning, the ultrasound, the nuclear. This is for sake of completeness. If you're looking at these slides afterwards, I've picked out some of the examples. Now, I should have, for those of you who have not used the ISTT website, I should have mentioned at the beginning that when you click on one of these, you get a description. You should, in some cases, you get a diagram, and what you also now get is a list of ISTT, International Society for Trenchless Technology members. So these are corporate members of the 28 societies that can perform a particular technology. And you also get a link to any existing papers on the ISTT's library that relate to that topic. So in theory, you could click on ground penetrating radar, you get a description, you get a diagram, you see a list of who actually does it. So that might give you some people, some peers to contact. And if you want to do a bit more research, it will link you to any existing papers amongst the 2,000 papers that the ISTT has on its website. So when it comes to operational performance, so this is the sort of final element of it, is looking at what's going on with, say, infiltration or inflow, what's going on with leaks in pressure pipes. And there's a final mention of, not so then it's not forgotten, there's various valves, safety equipment, etc. on a pipe, which must also be considered. So as it states obviously there, operational performance of a system is usually strongly connected to its physical condition. And we can therefore apply a number of different techniques. So if we're looking at infiltration and inflow, we've got here flow monitoring. It's also flow quality, chemical biology. Now, one reason for that is, particularly if you're dealing with industrial wastewaters, chemical plants, or you're dealing with sewers, and also if you're just dealing with drinking water, the quality of that, what is flowing, may well relate to the condition of the pipe. So there may be that you've got a particularly noxious or particularly corrosive situation. And let's not forget as well about gases, airlocks, etc., accelerating, say, hydrogen sulfide attacks on concrete. So we can do flow monitoring. We can monitor quality. You could have some in-pipe camera work, or maybe permanent cameras operating. There's the smoke and the dye testing again, and also just detecting overflows. So the performance of storm overflows is an aspect of condition assessment. So when they are operating when they shouldn't, you know something is wrong up the system. So all of these fall under trenchless methods for determining the what is happening with operational performance. I've put in a little bit more information here. So we'd be looking at things like discrepancies in flow monitoring data, changes in flow monitoring. For those of you who work with pressure sewers, the realization that actually it's the whole pressure regime can be can indicate a problem, but it can also be the problem, the cause thereof. And differential pressure monitoring is another method that can be used to try to show up where there are anomalies or leaks. So again, there's a little bit more detail here if you're looking at the slides afterwards. And leak signature detection, for example, using acoustics. And you can do this as surface surveys, or you can do it within the pipe. And of course, one of the earliest trenchless techniques, which is still used, is where you see the guy walking down the street with his little listening device that he can put on the road, he can put it to his ear, and he can actually himself hear what is going on under the ground. The most basic technique for discovering where a leak might be. Probes, microphones, operator walks along a pipeline. So a trenchless technique is literally to walk along the surface and look for a leak, or use something like a drone or some other method. And let's not forget here, you've got things like, particularly at the moment with our dry conditions, how is the vegetation responding in the area around where a pipe is known to go. This will indicate whether there's a leak present. So I've got down here under detection within the pipe. This is perhaps having a tethered acoustic system, equipment or a free swimming. Let's just bear in mind that a couple of ways of applying these is quite often, particularly where a pipe is still flowing, is you can use a parachute to drag your instrument down through. Or it might be you have a free swimming one, which is just dropped in and it travels along the pipe, carried by the flow, sort of smart ball or something along those lines. And this sort of, again, I have already touched upon this, I realise, with the above ground surveys. So you can look for thermal effects, vegetation changes, presence of chemicals. So actually another technology is training a dog to sniff out the smell of chlorine or sniff the smell of gas. That is another method which is being used. And this just emphasizes again, you can use aerial, vehicle, foot or traffic surveys, and or having perhaps discrete monitoring in locations where you're expecting something to happen. We've got, finally, this is the last item on the list, which is that there's a whole variety of operating components and monitoring and safety systems. So as part of the operational condition, these should be looked at. And for those who've had anything to do with pressure sewers, rising mains, there's an awful lot of occasions where, for example, an air valve is not functioning any longer, and it actually therefore becomes one of the reasons why the system is failing. So this is one of those operational things that should be looked at, is all of these aspects. And just physical examination of a manhole where you can see evidence of corrosion implies that there is an issue within the pipe which should be followed up. So a whole variety of applications, and that has been my very quick run through of asset condition, and previously very quick run through of site investigation. There's lots of information on all of these now available on the ISTT website. So thank you. I will stop sharing, and I think what we're going to do is to take the questions at the end. So I think it's over to Jack and Sean to talk to us a bit about how drones are being utilized to aid these systems. So over to you, Jack.
Brilliant. Well, thank you, everyone. And actually, our first speaker today is Sean, so I'll hand it over to him.
Yes, thanks, Jack. So we're going to start just with a brief introduction on how MIET, our environmental techniques, have been using drones for our surveys. And then Jack from Good Friday Robotics will chat about in more detail about what's possible with drones today and share some real life examples from some projects. So Good Friday Robotics, they actually develop and build and fly their own drone systems. And so there's a problem that many sewers across the globe, and including the UK and Ireland, remain unsurveyed. Why this is because of incredibly difficult conditions with limited access, high flows, debris buildup, presence of hazardous gases. And for some larger diameter sewers where we find big problems in getting them surveyed, is that traditional methods involving the human entry have high risks associated with them and require vast resources and a lot of planning to make sure they are done safely. And you can see their confined space incidents account for around 10% of all work-related deaths in the UK. So traditional systems like crawler systems and the float platforms, they have a vital role in the sewer inspection work, but they do have limitations. So the crawler systems, they can struggle with uneven inverts or where there's debris and blockages in the pipes. Float systems can require very specific flow conditions to allow the platform to pass through the pipeline. So on the example on the left, you can see where our crawler system is stopped at a bend. It hasn't been able to make its way around the bend, and there's actually a hole in the invert where it kept getting stuck. So with the drone, we were able to fly over the crawler in this instance and complete the survey around the bend, around multiple bends. So in some cases, there's only been human entry, which has been possible in the past to complete the surveys, which can bring serious risks, including the toxic gases, slip and trip hazards. This example here on the right shows a pipe in Scotland, which has a large cascade with a high fast flow coming through it. So we wouldn't want to risk anybody to try walk up or down that cascade. But the drone has been able to fly through that no difficulty. And with these large diameter sewers, there's risk of drowning with the high water levels. And there are difficult rescue procedures which have to be planned and put into place. So Scottish Water, they had identified that this was a problem in their sewage network with many of their sewers unsurveyed from the time of construction. So what they had done was approach their tier 1 contractor, Caledonia Waterlands, and asked them to come up with a solution, an innovative solution to survey these sewers and to do it safely. So environmental techniques as CWA survey contractor, we were brought in to work with Scottish Water, CWA, and also Northern Ireland Water to explore the solutions. One of these solutions was the drone usage. Is it possible to fly a drone down a sewer? So this was a question we put to Jack at Good Friday Robotics about 3 years ago, I think, Jack. Jack said it is possible, but incredibly difficult. But he did accept the challenge of working with us to turn this idea into a working solution. So the last 3 years have been exciting development journey and one that's showing good results out in the field. So some advantages of the drone. So by removing the need for people to enter the confined space or the hazardous environment, we've seen increased safety for our site personnel. At the same time, the drone surveys can be carried out faster with better quality and better accuracy and with fewer resources. You can see this example here. There's times we've had between 12 to 15 people on site to survey a pipeline, but now with the drone, we can do that with maybe 2 to 3 people at the very most. The drone also comes with a lower carbon footprint, with fewer vehicles, less equipment on site, shorter time on site, and it also reduces the traffic disruption with only needing one manhole open at a time. So overall, it's been a more sustainable and efficient and safer approach for our way of surveying. So I'll hand over to Jack now to go into a bit more detail.
All right, brilliant. Thank you, Sean. So basically, everyone, the purpose of the aircraft is quite simple. For confined space investigation, going in to understand your asset with human entry is an incredibly dangerous task to do. Actually, sending people into these assets can be incredibly dangerous, but also for environmental techniques 3 years ago, sometimes it was the only option in order to actually get an assessment done. And basically, the purpose of the drone is to be able to go in and get a condition assessment without the need for human entry. So for a wastewater survey, such as the one that you see, some of these assets, because they're impossible to survey, haven't been surveyed since their construction. And in order to do rehabilitation or even know what's under the ground, an assessment needs to be performed. But oftentimes, and actually this video highlights really the usefulness of the drone, there would be no other way in order to complete this assessment without being able to fly. There is no robotic system in use at the moment that would be able to see this little cascade here and actually overcome that obstacle. So that would be a survey abandoned at that point. And then the use of the drone being able to do this means that we're able to just fly over top of that. So all of us here in the masterclass, basically, what the purpose of going in and doing a condition assessment is to understand your problems, understand the defects, and then understand also additionally where they are. So Sean, we can pop to the next slide here. So here we have our drone flying along. This is what basically it looks like, what it does as it goes along. It's lighting its own way. But what you see here is actually a survey in a 700 millimeter pipe. And I'll carry on to the next slide to kind of explain this more. So this is the LiDAR and what the drone does as it travels. We'll actually go to the next slide here, Sean. So 3 years ago, when Environmental Techniques first contacted us, we were first contacted for these large diameter sewers that were normally done with man entry. And is it possible to create a no human entry system? And then whenever we sort of discovered after the first initial trials of using aircraft to survey these things, that it was possible to do these large diameter sewers, the next question was, okay, can we go smaller, and can we go smaller, and can we go smaller? And through working with Scottish Water, Dawson Lamb, Environmental Techniques, Northern Irish Water, Caledonia Water Alliance, basically we've gradually been pushed to see if we can survey smaller and smaller ones which wouldn't even be applicable to man entry, but actually just that they were impossible to survey otherwise. But when you get down to these ultra small diameter tunnels and pipelines, the drone begins flying within its own turbulence. And whenever the drone is flying within its own turbulence, you start to get a very, very unstable system. And this risks crash, risks loss of the drone, risks the drone going into the water. And so stability systems needed to be designed. And basically how we designed these stability systems is we had to work out the position of the drone within the actual pipeline in 3D space so that we could apply stability techniques to keep it in the middle of the pipeline as it does a survey. And in positioning the aircraft for safe flight, we have to calculate its position in 3D space. And in doing so, in calculating the position in 3D space, we also calculate the position that everything the drone sees in 3D space. So here you see as the drone moves along. Now it looks like that's a remarkably simple thing. Of course, the drone moves along and it sees things, and that's what builds the map. But this is actually the product of thousands of hours of engineering in order to do sensor fusion, to build all these different systems to calculate its position in 3D space. But if we go to the next slide here, Sean. What this allows us to do is each frame that the drone sees can be overlaid on top of each other and overlaid on top of each other in order to create a full 3D digital twin of the asset. And so what you're seeing here in all these images that are scrolling by on the screen is the point cloud product, the LiDAR product of what the drone produces as it flies through. So basically, if you imagine, as you've may have used before, the little measurement tools, the laser measurement tools, laser tape measures that you can put down on a surface and press a button and it'll tell you 1.20 meters or something. Basically, we have those on board, but instead of grabbing one measurement with a button, it is grabbing 600,000 measurements per second and then reverse calculating its own position based upon those measurements. And then as it goes along, 100 times a second, updating that to build up this full model. And then, of course, we get not just where the drone goes, but also all the measurements inside the structure, the asset that we fly through. So we can go to the next slide there, Sean. So basically what that looks like is here we have a hill, which we know a sewer to be under, and then we can go to the next slide and we can start to see exactly by using this method, we get to see where that sewer goes, where exactly those defects are. As I said before, it's important to know in condition assessment, one, what your problems are, to what the defects are, what exactly it is that you're doing. Is it missing concrete? Is it connections? Is it blocked connections? And the third important one is where do they occur so that rehabilitation can be done. So we can go to the next slide there, Sean. So there's our full LiDAR model of this asset. And then we can go to the next slide. And we can begin to add where exactly these defects occur, what diameters we see within them, where the diameter changes are, where the missing concrete is, what's the deviation of the line, what's the size of this line. We can go to the next slide, Sean. So basically, as the drone's flying through, we're taking measurements of the entire structure. This allows a full digital twin to be made, and then that digital twin can be used to measure all of the measurements that you need to take inside a structure to calculate any form of rehabilitation that you need to do. We can go to the next one, Sean. So here we see a storage tank or an overflow tank, sorry, or main collection chamber actually. So here's one of our externals. And then as we go in, we're able to get that full understanding of what exactly is going in. Of course, we're producing a video every time of the asset that we fly through, but we're also producing these. And these allow us to go in after the fact and get all the measurements that are necessary to a high degree of accuracy so that rehabilitation work and condition assessment can be properly planned out. We can go to the next one, Sean. So the drone has to, as it flies underground, obviously we don't have access to GPS. There's no way that a GPS signal can get down into our tunnels. However, we do produce this full model. And then we can take the above ground scans that we do have access to GPS and accurate GPS. And we can align everything and fuse these models together to give us a GPS fusion that allows us to see the exact pipeline's position as it travels under critical assets. This means that we get to know where the defect is and know where the defect is and what it occurs under, such as, here we have a railway scan and a culvert that goes beneath the railway. Is there any problems that are underneath the railway that need critically addressed? And then we can go to the next one here. So producing digital twins of assets, it isn't just an important one. I know actually this is perhaps a previous technology, but one that's important to point out is this method can be used for internal and external assets. And so here we have a full model of a dam structure. And the process of producing these models has improved significantly. So almost all the information that is captured in a video survey can actually be preserved and presented in the full 3D model. So we can go to the next slide there, Sean. Basically what that looks like is a full texturized model that gives you exactly what the condition of the concrete is as the drone's seen it. And being able to then use this to properly plan out remediation work, because knowing what a structure is currently can be the most critical tool in planning out the next steps, the next bit of remediation, modeling the structure. That can be the most critical piece of information that you can get in order to complete the work that needs to happen. And I think that's pretty much us. So thank you very much, everyone, for listening and sort of finding out what's possible. And I'll hand back to Ian, I believe.
Thanks very much. Something I meant to stress in my presentation is that many, particularly when we were looking at where our assets, if you're lucky, there's an as designed diagram, but there's rarely an as installed diagram, as I think you've discovered, Sean, with some of your flying of your drones through some of the pipework. So we really don't always know where things are. So this whole site investigation is absolutely critical, then linked to the condition itself. So thanks very much for that. And we'll hand over to our last presenter, which is Silvana, who is going to be talking about CCTV use thereof.
Thank you. Jack and Sean, that was a super cool presentation. I learned a lot in that. And I guess I'll be talking about kind of the other side of things, of maybe where you don't need to fly a drone. What do you do? So a very brief overview of, I guess, more traditional CCTV, cameras, crawlers, manhole inspection and some of the innovations within that field that Ian alluded to in his overview. So I work for Sewertronics, but previously worked for Minicam, and got my start in the industry in pipe inspection. So although I don't deal all the time with inspection anymore, we'll be kind of presenting on that here. Did that switch slides for everyone? Yes. I'm just gonna assume
Sorry,
so.
yes, it has. Yes, it has.
It has. Okay, it didn't on mine for a while. So yeah, a brief overview of what different solutions there are, going a bit more in depth on when you would use certain solutions than others that Ian did in his overview, and then kind of going into what does a survey look like when you're out in the field at the manhole, what does that look like? Because until I had started working in this industry or in this segment of it, I had never kind of seen the back end of a survey. So hopefully that'll be interesting for people to see what does a survey look like when you're out there in the field. And then very briefly talking about some of the innovations that are going on in CCTV. And I think maybe we have someone here, I saw him earlier from Vapor. So I don't know if he's still here, but maybe when we get to that point, I've put him very much on the spot if he's still in this call, but he can jump on and join in that discussion as well. So Ian talked about it, but kind of the most basic CCTV solution is push cameras used for very short inspections, suited for kind of that quick look-see that I think Ian, Jack, and Sean have all kind of talked about of what do you need to see is going on very quickly before you decide to rehabilitate. Even if you're on the site pre-lining, you've got to see what's going on before you put the liner in the ground. So it's really suited for quick inspections, some pest control applications as well. It's the right equipment for shorter distances and smaller diameters. So the push cameras that you guys see here, the max length on them is up to 120 meters. So you can't really do long, big runs on that. But you can put a variety of different camera options on it. And these are all the industry ones, not just this brand that's on the screen right here. So you can put cameras on to do different zoom, pan and tilt options. And some will have full reporting software on them. So in contrast to what I just said of if you just want to use it for a quick look-see, if you do need to run a full report and code on it, you can code on push cameras as well. So if that's required for the site, it can be an option. There's also something kind of on the more plumbing residential side, where if you really just need a quick look to go down any sort of plumbing, you have a camera option that can connect to your phone. That's becoming quite popular in the industry overall, having more phone and tablet access rather than on like a control box like you see on the one picture of the guy using it in the drain. If you need just quick look, saves to your phone. So that's becoming quite an industry trend with some of these push cameras as well, which is quite interesting as we all become more connected. So push cameras are the really simple solution. But on the other end, before you get to drones, which are crazy cool inspection solution, you kind of have in the middle of crawlers, and they're not fully capable, like Jack said in his video. If you came up to that stopping point in his example, the crawler wouldn't be able to go over that. So there are limitations with crawlers, but overall, they are quite durable solution and made for a wide variety of diameters. So from about 90 millimeters up to almost 2 meters in sewer diameter, they can inspect. So made for those larger diameters, often storm sewer as well, are suited for crawlers. And they're quite modular, they're quite durable. Almost all of the industry solutions offer the wheels that come on and off. So it's not just stuck with these black ones that you see on the pictures here. You can put different ones on for different pipe thicknesses, surfaces. If you have a really greasy pipe or anything like that. So they are really plug and play to kind of adapt the crawler solution to the pipe that you're in, that you need to see what's going on in. A solution as well that Ian talked on in his presentation that's becoming more popular in certain regions where you don't have as much access are lateral inspection solutions. So that's the crawler that's on the right-hand side of the slide. And essentially it is just a push rod on a crawler. So you can crawl down into the main line, and when you get into a lateral or you see a lateral, you can rotate the camera push rod head on it so it aligns with the lateral, and then push the camera up into the lateral about 40 meters. So if you have access issues with accessing the lateral from either the house or from whatever kind of top end side of it is, like in the US, you're quite restricted with access over there. So if you need to survey the lateral through a main line, these lateral inspection systems are becoming quite popular to do that sort of inspection. And they are really, really quite the new trend within the past 5 or 10 years to look at different inspection. Yeah, all of the crawler systems here offer full embedded reporting software that I'll get into the example of how you would do a survey, how you would do that in a second. But if you need to code to certain country standards, it's all embedded there. So you can either code exactly on the van, on the crawler system, that you're there right at the manhole, or you can take that footage away and code it later, or you can put it through AI platform such as Vapor, who I don't know if Declan's here.
I am here, yeah.
You are here. I'm sorry to put you on the spot.
That's okay.
But Vapor is a great platform that I'll shout out in a little bit to do coding for you there. As you can see here, you can run these systems off a van, or you can run them on a portable system if you need to access something out in the woods, something really hard to reach. We have some people that run them off of like Kubotas. So it doesn't have to be from a large mainline inspection van. You can run them much more portably. So there's a very brief overview of kind of crawlers, push cameras, and Ian also spoke a bit about manhole inspection. If my slide, there we go. So Ian spoke more on the kind of, you drop a camera down and it will be able to zoom through the pipe from the manhole. But on the other hand, kind of, there has been quite an interest in manhole inspections of the manhole itself, because they are also an asset that does need to be either rehabilitated or completely changed if there's big issues with it. So these drop cameras, such as this Rhino Vision 1, offer manhole surveys within minutes. So they have kind of a 360 camera on them, and lights, as Ian talked about, lights are quite important in the survey to ensure that the footage is being captured visually correctly. So very similar principle to either a push camera or a crawler inspection survey. You drop the camera down and yes, sorry. Adam, do you have a question? I'm happy to answer.
Okay.
Yes.
Sorry about that.
No, it's okay. No worries. I saw the hand go up. So yeah, these tripod inspection systems, or just straight on a pole, help detect structural damages, blockages, or issues in the manhole. And as Sean talked about, it is a huge safety concern to have people enter a confined space. This manhole is right here in this picture. It's off on the grass, but often that looks like it's in the US, that picture probably, but we all see manholes here that are not off in the grass, and there's huge traffic disruption, personnel involvement to have someone enter that confined space. So doing it with a camera is much quicker, much easier, obviously much healthier and safer for teams on the ground. So another quick solution as well, if that is, you have that in your toolkit. So very briefly on kind of the tips for how a survey would look like, how best to run a survey. You need to make sure you're kind of set up to succeed. So there's top tricks about how to make sure access is right. So with a crawler, you'll see in this picture here, someone's using a top roller for the manhole. So that preserves the cable and reduces friction for potentially longer runs. So if you're crawling hundreds of meters, that is quite essential to make sure that the crawler is still able to crawl at a relatively fast rate. Push cameras, you can set up a similar thing with a small elbow of pipe to enable a smooth transition into a pipe, particularly if there's a steep bend with it or anything like that. So it helps preserve your equipment and just make it easier for you. Because a lot of the crawlers you are automatically parsing out, but the push rod, you are manually doing it yourself. So want to make that as easy for you as you can. And yeah, with the manhole cameras, as you saw that one, someone was using a tripod for more steady images. You can do it on just a long pole as well, but of course the tripod makes it steadier and easier for you. As the people are operating these surveys now, it's quite important, obviously, to be trained, but also to just remember to be pipeline central. That's quite important, especially if you're coding, to make sure that you are in the middle of the pipe to have the best visibility of it. So there's extra tools that I don't have pictures of here, but you can put skids on your push cameras or different wheels or arm adjustments. So wheels to make you higher up in the pipe with your crawler, and you can adjust automatically the arm of that camera to make sure you're in the center of the pipe. So just some tips to make sure you're ready to survey correctly. So when you're in the survey, I think Ian talked about it, probably one of the most important things for visual surveys is your lights. So all of the solutions I've been talking about here have lights on them. You can also add on extra lights to make sure if you're really far down the pipe that you want to have adequate lighting to illuminate the pipe. And lighting conditions will change. You can control that as well on your end to make sure you're illuminating what you need to. Speed is also really important to make sure you're not going too fast, to have the camera miss something, not going too slow, obviously to optimize your time and optimize the time that you're, blocking traffic, having people on site. A lot of these solutions, particularly the crawlers and the lateral systems, have cruise control. So a button you can hit like you would on a car, and it'll just crawl at a certain speed. That's quite helpful for really straight runs or runs where you're at a really slow speed to focus on the condition assessment and not focused on, constantly adjusting what your crawler is doing. As well, particularly with larger cable reels, something on a van, it's better to have an automatic or semi-automatic cable reel to help with just paying out that cable more evenly, more consistently. And this will help as well with preventing accidents and being, focused on what you're doing. An issue that we see a lot in this industry, and CCTV is not alone to it, is recruiting people and making sure the people are properly trained. So with automatic cable reels, it's easier to have one person or kind of one person, maybe two, running around manning the survey, so you can focus more on what you're doing and have less people doing manual jobs. So in a survey, in the control box, so that's the box that was on the push camera or is on the crawler, that is the thing that's controlling the system. That can be either done in a van, on a proper PC computer, or it can be on the box that's on the unit. So you'll go through, and a lot of the softwares, this is an example of one that we've taken screenshots from. A lot of them are functioned the same. WinCan is the one that's embedded here, and a lot of other systems run off something very similarly. So it'll prompt you to enter data on where you are, what the pipe shape is, what the diameter is, what the material is, and you can enter all of that in different sections. And once you go into your full report, that'll be in there as well. So while there is training that is needed, of course, to do a CCTV survey, a lot of the newer control boxes and softwares make it quite easy to run through it. That's how you'll kind of function the survey. But after the survey, if you're fully coding on it, you can check your work on site to make sure you haven't missed anything with survey previews on this control box example. So this is the minicam control unit that screenshot was from, and that's what MCU stands for here. So that's a function of it. You can check your survey, see what's going on. Do you need to go do another quick pass, look at something before you leave the site? Because once someone leaves sites, you don't really want to go back. You can upload your reports instantly to WinCan Web or any other cloud-based platform with Wi-Fi connectivity. And if you're doing a fast pass, if you only have a certain amount of time to access a site, or if you are utilizing AI, you can then push and directly upload your surveys to AI platforms like Vapor that I've shouted out here, and unfortunately have put Declan on the spot for, or you can use WinCan AI as well. But if you run old footage, if you have been to the site multiple times, every year, every certain frequency, you can have all that footage into these AI platforms to kind of create a time frame of what the conditions have looked like and have changed over time. I have no idea if he really wants to come off mute, but Declan, I don't know if you want to come off mute and very quickly chat about Vapor. I am 100% putting you on the spot here. You can say no if possible. I'm sorry for putting you on the spot.
No, that's okay. I can speak to it. I'll try not to sound too salesy. That's not really my role, but yeah. So what we do at Vapor, I can only speak for CCV and the pipes. I know you got a lot of AI, like artificial intelligence, and LiDAR as well, but within this pipeline asset, the AI will chop the images in the video into different frames, and then there's a library of defects that we'll have. So in the UK standard, I think there's over 200 or 300 defects. So it'll see those images and it'll go through the library to try and find the best quality output and reference of the defects they'll find within the pipe. So and then rather than watching a 10-minute video, I've seen half-an-hour videos of within the sewerage pipe, you just get maybe 10, 15 frames that tell you where all the large defects are. So hopefully this is the future, and yeah, like you say, removing a lot of these manual jobs that a lot of people don't want to do. But yeah, see where the innovation progresses. Yeah.
Thank you. Sorry for very much so putting
No,
you
don't worry
on the
about it.
spot. I'm sure that's not what you expected when joining this call. But that was a better explanation of the technology than I could have given. So thank you for that. If you're not using an AI-based platform, and if you're still in the MCU or any control software, coding yourself, you can put project drawings in. So similar, like we saw, not as in depth with the drones, but you can map using a Google Maps integration to kind of show where you are and where the assets are within a project drawing function. So that is integrated into your report that you're handing over to whatever client you're working with. So that's just the snippet of that here. And yeah, you can preview your report before you kind of leave the site, like I said, but this is what it'll look like. So there's a lot of information in here. As you can see, I think this is page 8. There's many, many pages of this talking about the defects, talking about different survey tools if you were measuring inclination or if you were measuring with lasers or anything like that, specific defect information that would be in your survey. So very briefly, that's what that would look like. I guess there's some Vapor information in here. AI, as Declan said, is one of the biggest, I think, innovation in the sewer. Vapor has been working with a fair amount of companies in the UK to integrate into their processes, and we've been working with them at Minicam as well. Minicam is also looking at developing a local AI function, in addition to continuing to work further with Vapor, just to help operators on various elements of the survey. So as I've talked about, it is really important to make sure you have the speed right, make sure you have the lights right, make sure you're positioned in the pipe right. And as people that are newer to the industry come on, that I think with training, we can just make that easier by integrating AI into the control box that says, hey, you're going a little too fast. Maybe let's slow down. Or, hey, the camera's a millimeter off of center. So innovations like that will not only help the analysis of the footage, but also will help the manual jobs in it, and hopefully make cascade down and help with some issues that we're seeing, like recruitment. Ian talked about it as well, but another innovation that was talked about at Sheffield, and I'll mention again, is Pipe Bot Patrol. So it's a almost £2 million project funded by Ofwat to develop and build an autonomous sewer robot that lives in the sewer. So continuously inspecting and raising alarms to make proactive maintenance easier. So Minicam, Northumbrian Water, University of Sheffield, EMS, and I believe there's another partner on that, but they're all partnered on that. And working to develop a prototype for this. So at the Innovation Festival up in Newcastle 2 weeks ago, this prototype with, as you can see on the right, was unveiled. So that's something that has been adapted to a Minicam crawler as they're a partner on the project. That will be, I believe, trialed, I think, later this year in an active sewer. And instead of using cameras, that is using different sensors to kind of ping and sense what's in the pipe. I believe I can't speak to what it's using, but I think it's maybe using sonar or LiDAR to kind of hear and see what's going on rather than just visually. So half of the Minicam office has been taken over by the Pipe Bot Patrol, and they're working on its home in the manholes and things like that. So it's been quite interesting to see that project evolve and how that may change some of the shape of our sewer inspection at the moment. So I think that is the rest of my presentation. I have no one else to put on the spot that I've seen has joined this call. Thank you very much. And yeah, like Ian said, I think we'll do questions now. If anyone has any on the presentations, or if there's been any thoughts on what else we as the new to trenchless industry can be presenting on, can be sharing information on for the next couple online meetings that we have. So with that, I will open the floor.
There's, I think, Keith Brazil. You've got your hand up.
Yeah, thanks for taking the presentation is very informative. I suppose I work for Irish Water, as they're known now as Ishgaren. I suppose the problem that we run into constantly is pipelines with flows in it. Maybe 20-30% of the diameter of the pipe is surveying underneath the water, the sewer water. I suppose that's the first question, or the first point I make. The second one is like the siphons, where they're, I suppose, constantly full. A lot of our siphons, they're single siphons where we don't have the option to shut them down. So the problem we run into is how to get an accurate representation of the condition of the pipe on both of those, whether, I suppose, 20 or 30% of the pipe is full. We have used technologies such as the drones. We've used electrode leak location, the flow through servers with sonar. I suppose we're looking maybe for a silver bullet that doesn't exist. So I'm just putting it out there to everyone.
Keith, we actually, I don't know how much I can speak to this. Maybe Sean might be able to protect me in case I leak any IP. So actually, before I speak, I'll let Sean speak first.
Yes, Keith, we've been talking to Finn about a couple of ideas around that, so it's possibly something we can talk offline about afterwards. But
yeah, absolutely, yeah.
Yeah, but Jack, if you want to give a bit of detail, just to.
Yeah, so I can give a little bit of detail. Ian actually somewhat referenced this earlier in his presentation on the multiple different technologies available. In Good Friday Robotics, we have, in the creation of the drones, also made a number of different innovations in regard to stability systems. Stability systems can be used for what we use them for, which is primarily for positioning a aircraft within a pipe and being able to navigate harsh airflows that are associated with that. But ultimately, liquids behave very similarly, and the same stability tech can be applied to ROVs or submersibles. Now, the difficulty with ROVs and submersibles is for siphons in particular. you have a significant flow in a siphon, and there is also significant debris in a siphon, which is far more likely than when flying an aircraft through a pipeline with minimal degree. Normally, we're able to fly straight through, but for an active siphon, generally you have ragging and stuff that's coming through. However, we have made a number of innovations within this regard for operating ROVs in a very similar circumstance to how we operate the drone, with very similar 3D outputs, identical to the point clouds that was demoed there, but instead of using LiDAR as a multi-beam scanning LiDAR, actually using multi-beam scanning sonar to achieve the same result. But I will let Sean actually take that one off, because it is still very much in development. So I'll let Sean take that one off with you and speak more on that offline.
No, that's great. Look, if anyone can get in contact with me, look, my details are with UKSTTD or anyway. But look, as I said, we're open to all new technologies. As I said, we've tried a lot of them. But I suppose we are looking for the perfect solution if that's at all possible.
That's great, Keith. It's a very useful point you've made, and it's something that perhaps is a new layer of complexity that the ISTT should be considering for its trenchless technologies. There's a whole variety of different benefits. There's a whole variety of different situations that these technologies need to be used in, and it's making it clear perhaps which technologies are suited to perhaps some of the more obscure or extreme situations could be useful. I'll make a note of that for the next ISTT Technical Education Committee meeting.
Well, that's great. No, I remember at one of the previous meetings we had here was, I suppose, we were looking at double siphons where we could switch one off and switch one on, that kind of thing. But, you know,
you don't have that luxury.
There's a lot of places in Ireland where we don't have that luxury, yeah.
Yes.
Okay, thanks all.
Okay, do we have a hand up for another question? John Kelch put one in, I think, the chat, which is, what software do you recommend for creating a 3D model from a LiDAR survey point cloud?
That's a fantastic question in how exactly the system works. So there is a number of different options that you can use for post-processing a point cloud. But the actual creation of a point cloud from the raw data that the drone or any other device gathers on site, and the stitching together of that into a cohesive, accurate, and as low drift as possible model is a very complicated process. We have 4 engineers at Good Friday Robotics that is their primary sort of point of research, to which we've developed specific visual LiDAR, radar sensor fusion methods in order to try create these models as we fly through. So there's no easy downloadable software that actually takes the raw output from a LiDAR scanner and you can just throw the raw output in and get a model out. There's a number of systems that are all integrated within that, especially you may see the sort of handheld scanners that are often seen more on site now for LiDAR scanning, that has the system integrated into the actual product itself. And you may see some other, like for DJI and DJI drones, their LiDAR scanning is done through GPS, and so you can fly a drone around and that will produce the point cloud for you. But most of these systems are locked in by the companies in terms of turning that raw data into a digital twin or point cloud model from that, as it's fairly locked in. But there is then many systems that you can buy into that come with the LiDAR and the software that creates the full model. And then after that, that can go into your like Autodesk, your SketchUp, your Civil 3D, SolidWorks, whatever CAD program, pretty much all modern CAD programs now accept a point cloud as an input, so that then with Civil 3D or engineering post in using that point cloud to actually produce outputs that can be used as that. And there's many standards that go in that.
Yep. Do we have any further questions? Perhaps if anybody does come up with a further question, please just butt in. I've got one more slide to share, which is about the next meeting that we're considering. I was discussing with Silvana. So having worked our way through the main technologies there, there's something they've all got in common. And this is the reason why Trenchless. And it's the benefits of Trenchless, or considering them. So here's just an example. And we are therefore thinking that making the September event one which is exploring more the evidence. And for example, the University of Birmingham is writing an all consequences calculator, so that their intention is to go beyond carbon footprint into looking at what are all of the different benefits. So you will actually be able to plug in some information, and it will give you a variety of options, of solutions to deal with, let's say, an installation or a repair. So I've just highlighted a few here. Reduce disruption to customers. And actually, many of the utilities we speak to say this is one of the most important things. It's as a consequence of that, you get fewer customer complaints. And that is, of course, what they're marked on. But then we've got the disruption to traffic, disruption to businesses. There's the whole issue of carbon footprint and how you calculate it. There's reduced costs. And then I've highlighted in red there. This is, again, the most fundamental issue at the personal level is safety, non-man access. So we are looking at that as the topic for the September meeting, exploring this. But we'd be very grateful if anybody here, after what you've just heard, and some of you have been to all of the events, have any ideas about topics you would like to see covered on this New to Trenchless. So if there's anybody who'd like to put their hand up or step forward with a suggestion, we'd be interested to hear. If not, you're going to get a survey, I think, from UKSTT, from Linda. It's time for us to follow up with everybody who's been attending these events and ask directly ideas, or what would you like? How can we improve what we're offering? And Silvana, I think there's a stunned silence at this point. I'm not seeing anybody necessarily putting their hands up.
It might have to be a survey then, but maybe that'll be good to give people time to think about what they would like to see.
Yeah.
And maybe chat with some of their colleagues about, what might they like to see. Additionally, we were chatting about it before I think the majority of people joined, but we know that sometimes this might be a hard time during the day to join if, you have everyone here has a day job that sometimes isn't conducive to a 2-hour long slot during the day. So please let us know, either come off mute now or send an email to someone at UKSTT if there's maybe a more preferred time that might work, like potentially a lunch and learn slot that we could move these to in the future, just to continue good engagement. So that's something we are cognizant of as well.
Yes, something I'd like to add as an idea. We mentioned earlier the road shows which UKSTT undertakes, and we've tried it out in Sheffield. It worked. We're going to do it in Bristol. We will be doing it in our events next year. These road shows, if you're aware of them, they are one day. We have some really interesting speakers, and you get to see a lot of kit, some of the latest stuff that's available. And actually, if you're looking at staff development, if you're looking at your own personal development, CPD, then actually planning and taking a view of the whole year for the events which UKSTT hold. And for each one, we're now going to have an afternoon event the day before. So at Bristol, it's a trip to Wessex Water. And when we've agreed shortly the events next year, we will be looking at setting up something equally interesting. You then have the opportunity to go to the hotel where the event is taking place for the night and informally network, and then you get to attend the event the next day. So these are great opportunities for meeting face to face. These are great opportunities for networking, and they're great opportunities for just expanding your understanding of Trenchless and seeing a lot of the kit that you hear about in person. So there will be a push in 2026 to encourage people to do a little bit of traveling, and depending on how much time you've got available, is to maybe pick out more than just whatever is happening in your immediate local area as an event worth attending in person. So I'm just going to ask if Linda or Lynn have anything else they'd like to add at this point as the full-time staff at UKSTT.
No, I think you've pretty much covered it, Ian. Perhaps a mention of the conference next March would be
Yes.
good. We're planning that at the moment.
Yes, there will be the one-day conference as well. So yes, we put this. I've just shown you the slide of the roadshows, but there's the conference too, where we look at in much more detail at particular issues that are of interest to our members. And Linda, we mentioned a survey. I suspect as membership manager, you'll be involved in that.
Yes, Linda's had to leave us, but yes, there will be a survey going out shortly, no doubt.
Very good.